All right. Thanks, everybody, for coming. We're going to go ahead and get started. Welcome to DEV317. This is a talk. Actually, I'll fast forward through. This is a talk on advanced continuous delivery best practices. My name is Curtis Reese. I'm a senior solutions architect with AWS. I'm joined by...
my name is Felipe Almeida. I'm a senior engineer with Code Pipeline.
So we want to welcome you to this talk. Thank you for giving us your time. I appreciate you being here. Just a quick show of hands. I know it's a little hard with how dim it just got, but quick show of hands. How many of you are doing continuous delivery practices today? Pretty much all of you. OK, good. I want to make sure we set some ground rules and help you understand what we're going to go through today. So what I want you to walk away from this session with is an understanding of some of the best practices that we've learned over the years. We want to help you understand how you can apply these practices yourself. And then we want you to achieve continuous deployment nirvana. And so we'll get through a little bit of a definition in a second, but I want to make sure we understand what we're going to cover in this talk. So in this talk, we're going to talk about various practices that we've learned to help you automate the safety of your deployments. We want to make sure that when you're releasing, you're not just testing the application, you're also ensuring that the business has continuity so that if something goes wrong when you do a deploy, you minimize the impact that you have on customers, and you can minimize downtime. And so we want to improve the safety of your deployments. And then I also, hopefully at the end of this, if you feel we've met your needs, that leaving positive feedback is good. And if you don't feel that we've met your needs, please come by and talk to us. I want to make sure that when you walk out of this room, you've walked away with something valuable. And that's very important to me as a speaker, and it's important to Felipe as a service team member. So before we begin, let's level set on what continuous delivery at AWS means. So we have a typical software development lifecycle where we go from source to build to pre-test to deploy and post-test. Continuous integration to us is everything from source through pre-test. So basically taking your code, building your artifacts, running your tests on that artifact, maybe running this in a pre-test environment. Continuous delivery, and I hope I don't stumble on this later in the talk, but continuous delivery for us is taking that continuous integration story and then adding on deploy and post testing, but doing it with a manual gate. If you are very mature in these processes, you can do what we call continuous deployment, where this is a fully automated end-to-end process. This requires a lot of work, a lot of time. You have to understand your risk appetite for you as a company. It extends beyond just the technology portions of it, really diving into what level of trust you have with your processes. So for the sake of this talk, we're going to cover the continuous delivery portion of this, where we have a manual approval gate before you go live. So continuous delivery best practices for us, we want you to have version source. So we want you checking your code into a version repository. You can use whichever one works for you. We have code commit that you can use, and we encourage you to use. But if you want to use GitHub or something else, that's perfectly fine by us. We want you to have some form of automated build process. So if developers check in that code or do a pull request, we're triggering some kind of automated build process that will then go through and build your artifacts. Once those artifacts are produced, we want you to automate that deployment process. So get that code out in a way that can be tested in an automated fashion. And we want you to deploy that to more than one instance. It's great if you deploy to one instance and it works, but we want you to deploy it to a pool of instances in multiple regions or multiple availability zones so you can test it for load and availability as well. We want you to perform things like unit tests. How many of you are doing unit tests today when you deploy your code? Good. It should be all of you. If you're not, great, we'll talk a little bit about that later. But we want you to be performing those unit tests because we want you to find issues fast. And you're going to do that through things like unit tests and integration tests. And then we want you to get to kind of a continuous delivery process, which is what we're going to show you some of today. And then the life cycle doesn't end once it goes to production. This is a flywheel. As you're building these applications, you're building them to meet your customers' needs, and you're going to iterate on those needs. AWS is a very customer-focused company, and we're constantly trying to iterate to deliver value to all of you as customers. We assume you're going to be doing the same process. So once these things are out in production, we assume and hope that you're going through and setting up operational dashboards to monitor them, gather data, and go through and complete that flywheel over and over again. So what this looks like in the form of a process is we've got this process off to the side that shows source to build to deployment to integration, integration tests down to production, deployments to production. we'll go through a little bit. The tools that we're going to use in this talk, because we have to use something to use as an example, we're going to use AWS CloudWatch for our monitoring. So the examples that Felipe is going to go through and show, and the stuff I have on the screen, we'll be using CloudWatch monitoring. For software development, we're going to be using things like SNS to do notifications. We're going to show heavy use of Lambda, so you can have serverless components of your testing to automate and reduce the amount of overhead. But we're also going to be using code deploy and code pipeline as examples of continuous delivery and continuous deployment. I don't want you to walk out of here thinking that this is just a big sales pitch for code pipeline. Please don't take it as that. You can use whatever tool is going to be effective for your system, for your applications, for your teams. Our goal is to make you effective in doing continuous delivery. I prefer you use things like code pipeline. I know Felipe does too. He helps build it. But the reality is we have partners that we work with that integrate well with AWS, companies like CloudBees. We want you to use the tool that's going to be right for you. So please don't walk away thinking this is just code pipeline. These topics and the things that we're going to cover do translate to other systems, but we have to use a basis for us to show you. So let's go back to that process flow. So we've got the flow. How does this map to a code pipeline? It's pretty much one-to-one, as you can see. We'll dive into this a little bit. So we've got the pipeline, which is the end-to-end process. We're going to level set a little bit so we understand we're all talking on the same page. We've got what we call stages. So a pipeline is broken up into stages. Each stage can be comprised of various actions, and there's what we call transitions, which allow you to go between stages. So a lot of what we're going to show you is kind of built off of this structure because it's based off code pipeline. So when a source code change comes in, it's going to start a run of your pipeline. It's going to create an artifact. It'll go through the build process, deploy to a testing environment, go to an integration environment, and then hopefully go to production. So this is kind of the high-level process of a code pipeline. So we want to start this as like a maturity process. I know some of you, like most of you, said you're doing some form of this today. Hopefully you're doing all of this. But we're going to show you that if you're net new to this, you can start at an immature state and evolve this over time to include more and more of these processes and grow these processes so they're more unique to you and your business. So we're going to start with a little bit of a simple example of just a simple deploy to a production environment. We're going to use code pipeline to push that deployment out to a couple of instances on EC2. So for the sake of simplicity, we're going to be using EC2 today in our examples. If any of you want to learn how to do this with serverless technologies or containers, we've got another talk. I think we've already passed that, but it'll be recorded and it'll be on YouTube, so you can watch that. You can download the deck on SlideShare 2 days from now. DEV309, where it's going to dive much deeper into CI/CD for serverless and containerized applications. For today, we're just going to focus on the simplicity of instances. But again, it will translate. So step one, where do we get started? Well, step one in this evolution is starting with automation. So getting things off of a simple operations or a developer's hands and taking away that undifferentiated heavy lifting, getting a script to do it, automating that process. So an automated pipeline should be defined as code. We want you to build things as infrastructure as code typically. Your pipeline should be infrastructure as code. So you can commit it to a version control system so that we can track changes, we can monitor it, we can lock things down. This is your pathway to production. And so we want to make sure that we limit who has access to this. And we'll talk about that a little bit later. We want it to be extensible. We know that each of you is going to have some kind of application that's going to have some unique testing capability. If this were a containers environment, we'd want you running your images through something like Twistlock to scan the images. For security, we want you to go through unit testing, UI testing, Selenium testing, things like that. So we want it to be extensible so that you can use the tools and services you need to meet your requirements. And so being able to call out to other AWS services is important, but also being able to call out to third-party tools is important as well. And then the biggest thing that we want you to walk away with is feedback needs to be fast. There's nothing valuable about pushing out a change, waiting 3 weeks for that change to provide that feedback, and having your developers have move on from that. So they're context switching. What you want to do is have a developer commit, run through a pipeline immediately, and get instant, immediate feedback as to whether their build was successful, whether it was released successfully, and then what challenges or issues may have arisen. So we want to tighten that feedback loop. Some opportunities for automation. There's lots of different places for this. Again, this is all level setting right now. There's various opportunities for you to implement automation. So things like our build processes, integration testing, obvious. Most of you should be doing that today. Health checks are another good place to start. But when we start to get into more of the interesting things around safety and building safety into your release portion, we want you focusing on things like synthetic testing. Testing more than just, is my server up and returning a 200? Is the application actually responding the way it's expected to? Imagine you have a microservices-based application where you've got the UI of your application, you've got the carts, you've got specific buttons on your screen that are showing prices. Imagine the pricing service fails. Your website's up, it's presenting everything, but when they go to click that button has no text. We want to be able to automate those types of checks to make sure that, yeah, that site may be returning a 200, but it's not functioning as expected. So we want you to automate that, because having someone manually go through that is not going to be the best use of your time. And then we want to look at things, opportunities for you to provide notifications. You know, where are your developers sitting? Where are their communication streams? We want you to take the time to blast those notifications to where they are, so we're not getting delays in communication. We want them to be visible. We want you to be able to use things like Slack and PagerDuty to automate these processes. So let's look at this in the form of build and unit tests. So we want to trigger a pipeline. So on source control, on change, we're going to go through trigger the pipeline. We're then going to automate that build. That build will go through, create tests. So we'll deploy to an integration environment, and we're going to run through various tests. So we've got 2 tests here that are going to go through and test on Chrome, and then we've got one that's an integration test that uses an end-to-end testing solution. So the way this looks when we run this through a pipeline is that change will go through, it'll go through and to get deployed, and then it fails on one of the Chrome tests. So the browser test isn't working. So that browser test is going to go through and notify CloudWatch events that there was a failed action, and we're going to use something like Lambda to go through and send a notification to Slack. So our pipeline, in an automated fashion, has now notified our development teams or operation team through Slack. We've got a great blog post on how to set up this integration. How many of you are using integrations like this today? About half of you. Good. That's what we want to see. The idea here is it's providing that fast feedback loop. And a lot of this may not seem like groundbreaking stuff, but for some people it is. And this is something that we do consider to be an advanced integration, because you can evolve this to be very complex. And so we're showing it to you in a very simplified manner, because the uniqueness of the complexity is going to be unique to each of you. And so we at least want a foundational level to have this. And so say we go through and run this again, and now the build fails. We can use that same CloudWatch event and that same Lambda function to go through and provide the same notification. So growing on this, we want to take you to step 2. Deployment health is a best practice. So now we've got some automation. We want to go through and actually start focusing on deployment health. What does that mean? So this builds on our foundation of automation. We want to validate that the service is working after a new deployment, and we want to make sure that we're avoiding doing things manually. So the idea here is not just testing that the application is up, but actually testing that it's working. So if we look at this in the context of a rolling deployment with code deploy, we're going to go through, deploy version 2 of our application to all of the instances in our pool. It's going to go through. If it works, great. We've successfully deployed our application. But if we go through and run that again, if it fails on one, it's going to fail on all by default. So we have to introduce some kind of complexity. So if you're just using this out of the box, this is the experience you're going to get. So we want to add safety to this. How do we add safety? Well, we add safety by validating each host health. We want to ensure a minimum percentage of our fleet is healthy after a deploy. We want to roll back if things don't go through. So say we get through that process and one of them fails, we wanted to roll that back potentially. How do we do this? We're going to implement some simple scripts. So these can grow in complexity. Again, we're starting with a base. Seems very uneventful, but it's actually a very powerful idea here. We've got this portion of our AppSpec.yml. This is part of our code build process or code deploy process. Part of our AppSpec.yml, we specify after the application start, we want to execute a shell script. What is this shell script doing? The shell script is literally just validating our expected result of that application. So making sure that after we've taken that instance out of rotation, after we've gone through, stopped the server, deployed our code, and started it back up again, the health check will check to see if it's 200. We want more. We want you to go through and actually do the validation. This is how you execute that validation. So if we put this in place and we run this same deployment again, it'll go through, it'll do this rolling deploy, and if we get to one that fails, what's the outcome? How many, by a show of hands, say that this is a successful deploy? Good. That's good. I don't think any of you raised your hand. Yeah, by default, this is a failed deploy. And the reason for that is, by default, 100% of your instances have to be deployed to in order for it to be successful. And this is where the idea of bringing in minimum healthy hosts comes in. So we can specify that for a deploy to be successful, at least 70% or some specified percentage has to be deployed to successfully. So if we have 10 hosts, one of them fails, we've got 90% healthy, that is how we validate a successful deploy. So not only in this scenario are we validating that the application has been deployed to these instances and that they're working, but that when the overall deploy has been completed, enough of it is healthy for us to consider this successful. You're going to choose this based off of your own company's risk appetite. Some of you might choose 100%. Some of you might choose less. It depends upon the nature of your application. So the complexity is what you can introduce here. This is a starting point, but it's very easy to implement and you can grow. So if we look at this again, and that deployment goes down to 6 healthy instances, we're now below that 70%, and this is considered a failure. From here, we can trigger a rollback. We can automate that process itself. So how do you implement this? It's very easy to implement. A lot of you can get started with this today. When you're configuring your code deployment, we have a deployment config portion where you're going to specify 2/3 healthy host. If you're doing it via the API, you can go through and specify this. Wonderful text stream here. We're using the type of fleet percentage, and you can specify the percentage. This is a great process that a lot of people should be using, but I would say not everybody actually does. So it's something that we use internally. And the idea here is if you specify that minimum healthy host, there's a checkbox to actually automate the rollback. So if the example that we used right now is a rolling deploy. So we're literally taking one of our existing instances out of rotation, deploying the code to it, putting it back. In the example of the failed deploy, 4 of those instances failed. So we're only at 60% of our instances in our production environment. We have to get that back to 100. And the way you do that is by automating the rollback. So we want you to be putting that in place. So if we look at this in the form of our maturity and growth of our pipeline, we've now added validation on our specific hosts. And so this is great. So we've got synthetic testing through our automation. We've got validation of our hosts. Everything validates, that deploy is successful. Now we want to do this in a blue-green deployment. And so this is a great evolution. Blue-green deployments, how many of you are familiar with blue-green deployments? Nice. This is much different than the crowd we had yesterday, so thank you. It's good to see. So a lot of you, like a blue-green deployment at its base is the idea of spinning up a parallel environment, a green environment, where you're going to deploy your application to, validate the health, and if it's successful, we're going to cut over. So in this example here, we're deploying to our green environment. It fails. That build or the deploy is a failure, but you'll note the elastic load balancer is still pointing to A. So we have released a failed deploy, but it hasn't affected anybody. This is something that we should all be exploring as a means to protect our end users during deploys. So if we go through and fix that, when we do this deploy, and it's kind of hard to see, it's the version 2 is changing on our green. If it goes through and everything's successful, the load balancer automates a swap, and now we're cut over to our green environment. Now, based on your own appetite for risk, we had some people come by yesterday and actually talk about this. How long do you keep that blue environment up? Well, it's up to you. It's really up to you. The idea is we want you to build fast, tight cycles of your testing. If it takes an hour to go through and do that testing, keep them up for at least an hour. If it takes a day, keep them up for a day. The idea is you might miss something in your testing, and you're going to have to iterate through those tests. So if there's something you miss, you update your tests. We want to keep that other environment available so that if you do notice something, you can cut over to it quickly, and you're not affecting your end users. Very simple and straightforward. So we're going to go through a quick example of what this looks like. So I'll have Felipe cut over.
So,
Yeah, talk up or speak up.
okay, cool, better. So in this demo, I will show you a pipeline orchestrating a Boolean deployment using code deploy for that. I've recorded the demo because I don't want you to keep waiting for things to complete here. So this is a very simple application. It's just like an HTML page. And we have this pipeline. This is the pipeline that's orchestrating the deployment. You can see it's a source action, a build action, and a code deploy action. I am here modifying the app to increase the version, and I will add this bad deployment phrase here. This will trigger a test failure. We'll see that. Let me skip this. Okay. So the pipeline will pick the change, will detect the change was pushed to the repo. So you can see the search stage starting execution. I will skip this, accelerate this. This is code building my application, and then the deployment starts. This is where the interesting things is actually happening. So here in code deploy, let me pause this for a moment. Let me go, okay. Oh, sorry. Okay, very good. So you can see there are like 4 phases of the blue-green deployment in code deploy. The first phase, code deploy, will provision an auto-scaling group, a new auto-scaling group. It will install my application to the instance in that new auto-scaling group. On the third step, it will shift the load balancer to point to this new auto-scaling group and remove the old auto-scaling group. And finally, on the 4th step, it will tear down the old fleet. So what I'm doing here is every time a code deploy change phase in a deployment, it will trigger a CloudWatch event. I have a Lambda function listening for those events. That once the event notifies me the new fleet is ready, my Lambda function will get the new fleet, will attach the new fleet to a test load balancer, and we'll run some integration tests against that load balancer. If the tests are failed, we will notify code deploy that the deployment is not good, and that's what will happen here. So you can see the deployment failing. The application is unchanged as expected. So let me skip here, and then we will fix the version here. So pipeline detects the change, code build starts building, and code deploy will kick in again. So this time, when the Lambda function is triggered, it will run the test will succeed. The Lambda function will call an API, a code deploy API, to notify the deployment is actually good. So you can see code deploy will proceed to step 3 and step 4. So step 3, code deploy is actually moving my new fleet to the load balancer. Okay. And it will terminate the old outscaling group. You can see here, it's like deleting. And the new version is live. So you actually don't need to hop around other servers to see this happening. You can watch everything from code pipeline. I just want you to have like some visibility on what's going on here. Thank you.
Awesome. I'll switch back over. Yeah, and the reason we want to show you this is it's really simple to implement, but you can grow this over time. You can make this as complex as needed. And what we want to show you is that using code pipeline or whatever tool you're using, like Jenkins or something else, there is a corollary to this. And we should be going through and putting these tests in place to ensure that when we actually release something, if there's a failure, we stop it from hitting production, or we limit the blast radius once it does hit production. And if we can go through and automate the deploy or the rollback, we should do that. It's very simple and straightforward, but this is actually very advanced for some people. So step 3, we want to segment how we deploy. So we've shown you doing this in blue-green deployments. We've shown you doing it in rolling deployments. We want to talk about how you actually do this via segmentation. So why segment? Well, we want to minimize the risk of impact on our deployment. So by breaking things up and deploying in smaller chunks, we can limit the amount of traffic that's actually being affected by it. So if something goes wrong, maybe you're only sending 2% of your traffic over to it. Maybe you're sending just your synthetic tests over to it. By breaking it up, we can minimize that. The idea here is also to be able to help catch things that go awry before the users do. You don't want to push this out to 100% of your fleet and suddenly people can't log in. We want to be able to test that and catch it early on. Pardon me. And then we want to be able to roll back quickly, naturally. So we want to break production into chunks. Again, we're just repeating the same thing over and over again. So typical segmentations, we want to start by region. So break it up by region. Within each region, you can go through and break it up into availability zones. So breaking down that way. Dividing that up into subzonal groups, and then within a zone, have a canary. So this is typically the approach we want you to take. We'll get into the regional aspects of it in a moment, but a base production deploy should start with, at minimum, a canary. So if you're just starting this today, start with a canary deploy and have the rest of your fleet. As you're growing this, break it up into multiple AZs, and you can have a canary within each AZ too, if you want. And the idea is you're going to deploy to your canary first, make sure everything works. If it does, deploy to the first segment, validate that it's working there, and if that works, then we'll go through and roll the deploy in unison to the remaining segments. And we'll do this region by region. And so to create this and to target these, you can use tags. It's very simple. You can use auto-scaling groups. The idea is you can very simply go through and tag the instances that you want for your canaries so you can target them with ease. And the way this looks when we modify our pipeline is just to go through and we've got additional actions on our production deploy stage. So we're going to deploy to the smallest segment first. We're going to run our post-deploy tests, go through again to the first segment and do its testing, and then go through and deploy to the remaining ones. And then what we have just introduced, I think on the 17th of this month, was the ability to do this across multiple regions. So previously you had to have separate pipelines for separate regions. Now you can actually go through and have a single pipeline that can actually do this across multiple regions. So you have one place to go to handle all of your deploys for your application. The way we test that things are valid is we want to go through and test enough data to ensure that things are working. So we want to leverage CloudWatch metrics. We can use Lambda. We can use CloudWatch alarms, so we can make sure no service alarms are being fired. And we want to make sure that the testing hasn't timed out. We can also use code for that. But the idea is you don't want to just test one. You want to have multifaceted testing. So you want to make sure we're looking at your application from multiple angles and multiple vantage points to ensure that it's working properly. And the way we extend code pipeline to be able to accomplish this is we've got various types of actions. And this is the same in other solutions as well. But the idea is some of this stuff only works for 1 hour. So test actions, Lambda invoke actions, and custom actions have a 1 hour timeout. And the reality is some of your testing may take hours. It could take a day or more. I've seen some companies that have actually had two days of build processes and testing. And so for that, we recommend you use approval actions, which have a 7-day timeout. And so we're going to show you how to leverage the approval action to customize kind of a approval gate. So using an approval action, we're going to blast out an approval message to an SNS topic, which will then trigger a Lambda that will go through, do our validation, and respond back as to whether that approval is good to go or not. And so the way we set that up is when we create that approval action, we're going to specify the ARN of our SNS notification. So our topic is going to go there. And then we're going to use the comment field to provide some JSON strings. And so we're going to have a JSON object here that's going to have specific information about that particular pipeline, that particular approval action, and then we'll use that downstream when we go through and do a release. So when we hit that approval, it's going to go through, notify the SNS topic, which is going to hit a Lambda function. That Lambda function then goes through and logs that SNS kind of packaged bundle into a DynamoDB table, which then we have a CloudWatch event monitoring via Lambda, which will go through and do the actual testing. And so the reason for that is We want your Lambda to fire and shut down. If it's going to take a day or more, you can't do that with Lambda. We want to put it somewhere where it can be stored, polled against, and then once we know it's valid, have it go through and provide that response so that release can continue. So looking at this in its components, this Lambda function is actually pretty straightforward. It just has a very simple event, which then goes through and takes that SNS JSON bundle and breaks it up, and then basically just a simple DynamoDB put. So it's going to store this data in the DynamoDB so that that Lambda polling can go through. I'm not going to explain how this works because this aspect is going to be unique to you and your application. What type of testing has to be done, the durations, the timing, everything is really unique to you. The important thing is that you do it. What I'll show you right now is that it's really easy to provide that response so that that approval can continue on. And it's just a simple code pipeline put approval method. So you're going to call that using the data from that DynamoDB table so that you can go back and mark it as approved. Pretty simple, pretty straightforward. But again, the outcome is very powerful. Seems almost anticlimactic looking at it, but this is actually pretty advanced and it works really well. It's stuff that we do internally. When we look at canaries, so going back to that conversation of breaking things up in segments, canaries should be a part of production. They should have traffic served to them. They should be configured as just any other production instance, but we want them to participate in their own metric stream. So imagine you have 1,000 instances in your production environment, and they're all getting metrics. You don't want your canary to get lost in that flood. We want it reporting back in just like any other instance, but we also want it off to the side, providing its own metric stream. So as you do your deploy, you can test it, that data isn't getting lost, and the validations can go through and pass. So we want to mark those as somewhat separate. So in summary, segment the production so that we can reduce impacts of bad changes, segment by region, use canary deploys per region, and then break things up as you grow zonally and subzonally, and then test each segment before moving forward. So we also want to call out step 4 of just deploying to multiple regions. This is actually a really important thing that is new as of November, as I said. The idea here is that you can deploy to multiple regions using the same pipeline. There's more reasons to do this than just the idea of getting it out to multiple locations. This helps alleviate things like latency for your end users. It also increases high availability. So your application is being deployed in multiple places. In the event that there is a failure, it can be served locally to the end users, or it can be served as a DR site. So having this be a part of your pipeline is important, especially if it's just for DR purposes only. So if we look at how this looks as we evolve our pipeline, our deployment, actually, let me go back. Our deployment is going to be broken up into multiple stages at this point. So one stage per each region. It's the same process per each region. Deploy to a canary, validate, roll through the rest of the deployments. So we'll show you a very quick demo of this one.
So again, this is a recorded demo. So it's a pipeline, it's a simple pipeline, but it's deploying to 3 regions, and each deployment is preceded by a canary deployment and a validation action. So for this pipeline, I chose to use cold build for the validation action, so I can just start a cold build, but instead of building something, I am generating synthetic traffic, and I am also monitoring CloudWatch metrics. And if anything is out of what I expect to see on the metrics, I will fail the validation. So I am changing this to return 400 in every request we get. Let me skip this. And you can see, like, pipeline will detect change, build. And you will see during the validation phase, the validation will fail. And there are a lot of more that you can do with a failed validation. For instance, you could not only stop your deployment from proceeding, but you can also remove the canary host from your load balance. So you will stop blast radius right away. And you can also page your engineers naturally. That's it.
All right. Let's hop back over. I think that's a good point. Somebody asked that during our last session. how do we treat canaries? Do we have to send traffic to them all the time? And the answer is no, you don't have to send traffic to them all the time. You can actually pull your canary out of rotation. You can send your application to it. You can test it locally first before you actually open it up, so you can further minimize that blast radius. But it is important to at least get it back into that production stream so that your tests can be executed.
Yeah, I actually think it's pretty interesting to have your canary receiving a customer traffic, because the customers will do things that your tests won't. So there are certain modes of failures that a test won't ever get. So if you have a canary deployment, it will only be impacting a small portion of your traffic, but it will get the deployment before it hits all the fleet.
Yep, and that's an important thing to note too, is as your users do things, they're gonna do things that are unpredictable. You need to be catching that. And so you're updating your tests over time and iterating them effectively. Another thing is we wanna implement pipeline governance. So the idea here is we wanna block non-compliant pipelines. Everybody should be automatically deploying to production. You should be deploying it. But we want to minimize the impact of, say, a developer creating a new pipeline, skipping past tests, skipping past different phases, and pushing code straight to production. We don't want to go straight from version control out to production. But one of the ways that we can do that is by implementing some form of pipeline compliance. The example that we're going to use here is with AWS Config. So we're going to build AWS Config rules that will go through, actually validate your pipelines, validate any changes that happen to your pipelines, and then based on the outcome of that, actually affect whether your pipeline can push code out to production. And so we're going to build a pipeline that uses approvals to pause production deployments, and we're going to use Lambda. So we've got two examples that we're going to show. One is just using native AWS Config and AWS Config rules to go through and automate the stage transitions, but one that we're going to show is just using Lambda, using the same approval action that we used before. So the idea here is as you go through and have a change go through the pipeline, once it hits that safety check, it'll call out using an SNS topic via that approval action, which will then go through Lambda to validate through AWS Config, where you've got your pipeline config rules set up, whether that's valid or not. If it comes back as passed, that approval gate is passed, and now you can release to production. Oh, that was a weird transition. So the idea here is we want to basically set up this safety check. And the way that you do this is you're going to go through, create a new config rule. This one, we're going to create a Lambda function that will go through and specify the Lambda function that we want to call anytime somebody updates. Sorry, I jumped through that really quickly. I want you to see this. So this is the screen. Yeah.
That's not a Lambda function.
That's not a Lambda.
That's AWS config rule. Right?
Yeah, the AWS config rule. So we specify the AWS config rule through this configuration that will go through and actually do the validation and then block the change at the end. So the way this one works is we're doing it at the stage level. Anytime we make a change to this pipeline, AWS config will fire off a CloudWatch event that will go through and validate that pipeline, which will then use a Lambda function that we specify to go through and block the stage transition. So here, that nothing can go to that production environment. So the difference here is, one, we had the Lambda function doing it as an approval action. Code to config here is actually doing it to block transitions. And the idea at the end of the day is just we want to make sure that we're blocking the releases to production so we prevent any actions or issues that might be occurring at that level. We want to be able to add common actions to all pipelines. So every pipeline should have some kind of validation check. And the way we can accomplish that is by using things like CloudFormation to give development staff, so as they're building out new applications, we can give development staff an example pipeline to start with. And that pipeline can have that governance built in. How many of you today have some form of governance process through your release? Not very many of you. Okay. This is a very important thing, and this is something that if you're in compliance and auditing, this is actually very important and powerful as well. We want to make sure that we can audit and show who has access to these things, who can actually deploy to production, and what are we doing to actually limit the releases to production in the event that some kind of compliance is out of order. So this is a really good way of doing that. And you want to basically use approval actions to go through. So we're going to show you just a really quick version of this in action.
So here we have this simple pipeline with three stages and three action types. And we will use Lambda function listening for AWS Config rules events. So this is the dashboard for AWS Config rules. I have 6 pipelines in my account here, as you can see, and all of them are compliant with the rules I have. So here you can see the rules I have configured. So there are like 2 rules today. One will check for multiple deployments in your first deployment stage. As a safety feature, we don't consider a good practice to target multiple environments on your first deployment stage. And the second rule we have here is we'll check for how quickly you're fanning out your deployment to multiple regions. You don't want to deploy to multiple regions at once until you know your deployment is actually good. So usually you go like 1 region, 2 or 3 region, and then like 4 or 6 or 10 later. You can also create your own rules. It's actually pretty easy. It's just a matter of writing a Lambda function. The console, you can do that from the console in AWS Config. It will just ask you for the name of the Lambda function. That Lambda function will receive your pipeline definition every time your pipeline changes because someone edited the screen. Edited it on the console or CLI or CloudFormation. So let's see it happening here. So I will edit this pipeline, and I will add a second deployment stage, a second deployment action to this stage. Let me just.
We're going a little fast too.
So the pipeline now has a second deployment stage, and we can see at. Let me skip here. So this is the actual Lambda function that I have in place. You can see it's. You probably can read the code, but you can see it's a pretty small function that I have.
And the reality is we'll be sharing this on SlideShare after the fact. So if you have trouble reading this, you can actually see it on SlideShare later.
So what this Lambda function is doing is it will be triggered every time the compliance state of the pipeline changes in the AWS config. So it will know your pipeline became compliant or uncompliant. And if your pipeline is uncompliant, that Lambda function will disable every stage transition in your pipeline. So you can see one pipeline I marked as uncompliant now. The rule that the pipeline is uncompliant with. And now we can check the transitions are disabled. You can also set specific messages here, like for the reason the transition is disabled, you can choose to page someone or notify on Slack, email, whatever works for you. Cool, thank you.
Okay. And so if we look at our process again, going back to our end-to-end lifecycle, we've now added safety checks here. So there's additional safety checks that you can actually employ outside of just config. So imagine that you're doing something like Black Friday and you have a code freeze. You can actually block your pipeline based off of Lambda functions. So you can say, you can have a release schedule or a code freeze schedule. And based on that schedule, you can actually block releases through your pipelines. So you can trigger those as gates. So there's great opportunities there to limit it to the time that staff is available. Maybe you have specific staff that's there 8 to 5, and we only want releases of 8 to 5 Monday through Friday. Great. You can actually go through and put those in place to limit when things can actually get released to production. So what we've learned so far is that we want to identify production issues quickly. We want to be able to do continuous production testing and automate the notifications so that we're getting feedback to our developers and our teams in the event that things have failed. We want to deploy changes in a managed way. So we want to deploy based on the health of our systems. We want to segment our environments to limit the amount of potential risk that we have when we actually get things out to production. And we want to improve latency and availability of our applications. So we want to be able to provide deployments to multiple regions. And then we want to automatically decide when to release changes. So whether we should be blocking things at specific times, whether we should be blocking things based on compliance. These are all processes that we use internally. I highly recommend you do that and use it yourself. If we look at it in the form of our ending point of our pipeline, and I think we'll talk a little bit more about a couple other things too. We've grown it from automated testing to validating and segmenting our deploys, to growing our pipeline to include testing with canaries, and then also putting things in place. We've got example code for all of this on AWS Labs on GitHub, so I highly recommend you go through and look at that. There are additional talks that dive deeper on this. Before I say thank you, I do want to mention a few things that other people brought up in our previous talk, things like database deployments. And so a lot of people came up and said, look, how do we handle database deployments through this process? Do we deploy them at the same time? Do we deploy them staggered? What's the process there? And the best advice that I have, and you might have different experience, but the advice that I had for people was there are specific design patterns that you can follow. They're available online. There's an open source website I don't have handy right now, but if you hit me up after this on Twitter, my handle is Boring Geek. I'm the only Curtis Reese in the world too, so you can Google me and you'll find me. If you hit me up, I can give you the URL to it. But the idea is there's specific patterns that you follow when you do database deploys. So I would actually stagger those releases between your code and your actual database structure, so that if you do a release that's maybe introducing a new structure in your database, you release that first. Get that out into production, get it running in the production database, and then as a subsequent deploy, once you've validated that everything's there, then deploy the code that would make use of it. If you need to do a destructive change, deploy the code first so that it's no longer using that structure, and in a subsequent deploy, do the destruction. And that's great for relational databases, but here at AWS, I'll let you talk a little bit about how we approach the database model.
Yeah, I think we do exactly what Curtis was saying, but we always make sure we have tests in the when you're deploying your code that will exercise the new structure. In that way, like if you're missing the deployment for the database, the code deployment will also fail and be rolled back, so you don't have impact. We also do a lot. We have something that we call pre-prod stage. That's basically a prod host. It's like a canary host, but it doesn't receive customer traffic. It only receives test traffic. So what we do is that way we will guarantee that before getting to the canary deployment, all the dependencies for your code is already deployed to that region because your test would fail otherwise.
Yep. Another question we had was on how do you do dependent deploys? So if you have a release that's going out that requires a specific version of a subsequent service, and the idea there is I would leverage something like GitOps. You mentioned another option.
I think it's basically the same approach that we use for database. Database is just a specific case of some dependence, right? So you can have, again, your pre-prod stage, make sure you have some test case exercising the new dependence path, and you will be fine because your code deployment won't hit production if your dependency is not available yet.
Yeah, and it's the same from the GitOps model. Your code should define the dependencies and the versions that it's expecting so that when you fire your tests can actually go through and validate that those versions are out there. And if they aren't available or the version of the service that you're trying to call isn't released or there's a mismatch, your test will fail, which will prevent that code from going out and being an issue. So there's lots of ways that you can grow this. Again, I do want to stress that we use code deploy and code pipeline heavily through this process. You don't have to use that. We encourage you to use whatever tools are right for you. We offer these as a capability that's native to AWS, and we encourage you to use them. But if you're using something like one of our partner solutions that we have deep integrations with, you're going to be successful as well. And this isn't just something that's tied to Linux. If you're using your Windows-based environment, you're using that stack, you can go through that process as well there. A lot of this are base primitives that you can employ holistically through your environment, regardless of the platform. The important thing that I want you to walk away with is that we want you to be successful delivering capabilities to your customers and doing so in a way that minimizes any risk or impact on them. You can grow these over time. You can evolve this. The key thing is to start with one and move through it. And maybe most of you, 60% of you, are doing some of these. I would assume probably 20% of you are already way beyond this and looking at me going like, that's not advanced. Congratulations, you are already doing advanced things. That's good. 20% of you, this may be net new. And so I encourage you to try this. And as you go along the way, if you stumble or you have challenges, find us online. Talk to us. Ask questions. If you have an account manager, reach out to your account manager. If you have a TAM, talk to your TAM. We will help you along that way. So I want to say thank you. We're opening, we'll be available for 10 minutes to answer questions. And then if there's additional questions, we can go outside. I appreciate again that you came and gave us your time of the day. We're also heavily focused on data. We're a very data-driven company, so please provide feedback. And if you find yourself giving us a 4 or 5, thank you. I really appreciate it. I'm glad that you walked out of here with something valuable. If you find yourself giving us less than a 3, before you push that button, come talk to me. Come ask a question. I want to be able to have you walk out of here with value and feeling like you got something that was useful for you. So please come to us beforehand. Let me make it right. So I appreciate it. Thank you so much. I wish you luck and a lot of enjoyment this week at reInvent. So thank you.
Thank you.